here. Maybe it can be here it's very clearly. So inside the folder that I will give it to you, it will be include the AutoCAD installer. You can use this to be installed it, but nowadays our program is compatible with just 2020. Lower is fine, but higher is cannot be done. So I already like the license AutoCAD to be that serial key. You can use this to register on the student versions, or you can have it by your own. Okay, after you install the AutoCAD, you should install into the die C only. We fit to the die C. Do not install to the AutoDive. It will be have the problem with our installer. So the second, after you complete the install the AutoCAD, you need to install the XC installer. They have the two installer. I recommend you to run double click the setup. Okay. So after you double click the setup to the installer, you can be run by the process. But however, I will show you how to install and remove it. This is when we would like to remove the program, we need to go to the control panel and see the XC in it, right? And install it. So it will be takes around 30 seconds to be removed and install again. Yes. Okay, this is everything is already removed it. And what is its impact to be shown on the program? I will show you on the 2020. Because now we try to test on the 21, still checks on the bugs on the new versions. Now we already removed the program, isn't it, right? You cannot see any kind of the ribbon. Maybe the ribbon is just belong to the AutoCAD itself. It's not have the additional ribbon that we integrated. Okay, so you can cross it and install by double click on the setup. And please select and do not change the directory, please. If you change it, I think this is not working to be readable. And click yes to be confirmed tab. Okay, now this is done. We can run the AutoCAD 2020 to see what happened. So every time it will be called automatic and lead our add-in attach and see on the ribbon as you see it. First, you need to click start drawing. After you click start drawing, it will be included. You can see that we have the 1, 2, 3, 4, 5, 6, 7, 8 ribbon that belong to us. So I do not nowadays maybe should be starting. You need to go to the Preprocess or OpenFAST calculate XC sport process first. Maybe later on I can teach you how to use the XC drawing GHbed or X OpenFAST. Okay.
The font everything not very clear. Is there any way to? No.
No, I think
think
no.
텔레비전 같으면 괜찮은데 이건 안 되는 모양이야.
Maybe no.
No.
Maybe let me try to reduce, but I'm not sure what is the effect.
그건 아니고 이 정도면 됐는데 이건 안 되는 거. 폰트 자체가.
Okay, it's better, right?
Yes.
Because I zoom it now. So, I think can you cross the line? We create all the screen because we need to use the grid line.
크게 하면 그 대신 저쪽 아이콘이 지금 저기가
Okay, so the first thing you need to understand about the XC AutoCAD, we have the three important program. The first is AutoCAD. Second is the GMatch to generate the match, and third is our engine XC. Okay, AutoCAD is will produce the IGES file and readable by the GMatch, and after that the GMatch will be exported to the AutoCAD forms again. This is a process that's we working on it. Okay, so to starting the model, actually maybe I go to here, explain first. Okay, I already prepared the two simple model. Maybe you already saw it on your under sheet. So the first model I will teach you is just a very simple beam for the cantilever. Everything is already provided. You can see the length is equal to the 6 meter. For the height of the beams, right, is 0.2 and thickness is just 0.1. Young modular orbital elastic is the 1 power multiplied by 10 power 7, right, and a 0.3% ratio, and we use the unit force at the free end to test it for the verification. The example will be checked with the x-axis displacement with the extension. Okay, you can see on this is a results right. This is the in-plane shear, this is the out-plane shear, and this is the torsion. Okay, to model in the AutoCAD is so very easy and simple. So the first thing you need to start with go to the home. By the way, I will teach you first how to change it. This is command menu is distract me so much. Okay, so by the way, in case of the AutoCAD, we have a lot of kind of it. Please be careful when you use it. We have the draft 3D basics and 3D modeling. Nowadays, I use the 3D modeling. So you can choose same as me, or you can use the draft when you use on the 2D. Okay, so we can go to the home, and we have the icon as the lines in it, right? I forgot one thing to be clear again. By the way, before you starting the AutoCAD, you need to check the unit of the AutoCAD first. The unit will be transferred to the GMatch, and GMatch transferred to the XC. GMatch always leads as the millimeter. Okay, we already have the unit convention to change it and convert automatically. So please check the drawing from the AutoCAD. So by using the type unit S, you can see that when they starting to setting, they always inch. Be careful on this. Okay, I will set on the meter to be export the model. After we set the unit, we can draw the and okay. This is the lines, right? I would like to draw with the cantilever beam. Can starting with the grid, start the point and drag it, and input the length equal to the 6 meter. Okay, now we got the line belong to here. So after you have the model, next you need to generate the mesh by go to the XC's preprocess. Calling the GMatch. So now it's just line is coming, right? Inside the GMatch, you need to go to the match option, define. Because in this model, we define just only 6 elements, isn't it, right? That means you need to define how many elements that we would like to generate on this line. And go to the time finite. into the curve. By the way, this curve is the number of the point. That means 6 elements have 7 points. That means we should put the number 7. And you can see it's on the top. They already create that. Select curve, right, by press E to be enter and Q to be abort or quit. Click here, press E to be confirmed. Process as is to be saved. What you change it. And press Q to be quitted. Cool. This is it. So finally, you need to click another sheet. Generate the match at 1D. This is already completed, but by the way, you cannot see the number, isn't it? We can go to the two option, match, node label, and element label. Now we already created. You can see and you count the number, okay? After completed, you need to go to the file, save match. This is very important. And close it. Or you can use the file and quit it also. Okay. If this term completes, you need to select on the open match. Once again. Now match is coming. Okay. To be checked about the number of nodes, you need to go to the label, and you see it. You can see after I click on the nodes, right, the number of nodes is coming, and even though we can see it's on the element label to be double check it, is this correct or not. And the first thing you need to clearly about the unit. What is the type of the unit that you are using inside the model? We can set on the basic unit and the match unit belong here. You can set many kind of it. But in this variation example is use the SI unit, or is just like the normally is a unit less. You can use the English units also to be modified. And second is the active DOF. This kind of the active DOF is special issue for the element that you are using, such as the frame. We have the 6 degree of freedoms, right? But our program include one more degree of freedom for the warping also. If you consider that, you can click here to activate it. If you don't want to consider about the warping, you can deactivate it. Okay, we can, even though we provide the spread touch frame select shell that you are using on it. Shell have 6 degree of freedom and solid have 3 degree of freedom. Okay, please be consider this before you understand what kind of the model and what is the element you are using on it. So the gravity types, we can define the axis also. Maybe this is not important issue much for this model, but it will be important to when you analyze on the offshore. You can define the gravity and modify the value. Okay, next we need to choose the analysis type. The program is already default to be the linear static. Maybe at the first time you no need to be change anything or do not touch anything. We have the non-linear dynamic, linear dynamic. Here we can input the force functions belong to somewhere, or the professor that mentioned about the couple analysis or semi-couple analysis belong to here. Okay, but by the way, I think you need to understand clearly about the linear statics first. We have the delta effects. You can include the earthquake response spectrums also. After you include the response spectrum, some important parameter for the ribbon will be coming. You can see it belong to here. Because now the ribbon is very short because I add zoom in, right? So when the LH length is not the same with the original form that we developed it. By the way, we can move it also. You can see it. Okay, now this is the OpenFAST. Maybe we can discuss later on. This is our still design and what is the code checking that, what kind of the code check that you would like to designs of the sections. Okay. So after you define the solutions completely, this is the monitoring, but it's not important in this term, but it will be important to carry out the results for the dynamic. I will not teach you this time because of if I teach you everything, it will be confusing, isn't it, right? So if we follow the example, the value that we need to change it is just for the material property. You can click on the ribbon as the material, and we can use the isotopic. Okay, you can see on the example, they explain about we must to use the 1.0 multiplied by 10 power 7, and with the Poisson ratio is equal to the 0.3. Okay, after you complete to modify, you can press OK to be confirmed. However, if you have the additional material, you can click plus sign, okay, and input it and press the OK. This is the additional material property, or you can delete by using this one. Can be deleted easily. Press OK to be confirmed. Then, so next we need to assign the frame section, isn't it? So we should go to the frame section belong to here, and we have the many types of the frame section like open, close, PSC, offshore, general, standard, or section designer. In case of the section designer, you can draw by your own, drag and drop as you wanted, or modify to be here, or even though the eye shape be here.
This one minor style here.
Yeah, you can change like the composite section that you would like to make it by yourself and change the some value, adjust it. Okay, so in this case, in the validations, right, they use the rectangular. I will use the instance sections property. We can double click on the section and you can modify the name. If you don't want it, it's fine also because it will be run automatically. Press the OK to confirm about the name. So W is they mentioned about the 0.2 either, and for the thickness is now 0.1. You can see the real shape by showing the preview when you input it, and you can check with the sections property to check about the area, torsional constant, first moment of the inertia and second moment of the inertia. Okay, press OK to be confirmed. Now we need to assign the section to the element. So we need to go to the X frame because we use the frame, isn't it, right? We have a lot of the type of the element. This is a shell, and this is our solid. The name is not coming because we zoom in. So if you zoom out, it will be changed, and you can see the name is very clearly. If I zoom out, you can see this is the name. It's much more clearly solid and shell frame. So you need to click on the X frame, select the cross section that you assigned. I use the rectangular one, isn't it, right? And select the number of the frame element that you needed by cover all of it because everything is the same. Press bottom here, plus on it to be added. You can see the number is coming. Finally, until this pass, right, we can see the rendering of the shaft by go to the rendering line or all. It doesn't matter. I change the view, and we can change even though the shade realistic. or some shade of gray, any color that you would like to be seen and snap screen. So we use the 2D wireframe and enable it. Okay, next we need to assign the boundary conditions, right? So we can go into the restraint like here. This is a cantilever beam, isn't it, right? It should be fixed conditions at the begin point. So we need to be click on active all of it, select and add it. Now the boundary condition is coming with some sign. One cone is mean translation. Double cone is mean rotation. What is there are you faking? So you can cross it. So now remaining load, we can go to the load belong to here. The specifics on the two kind of the load, general load and offshore load. Nowadays, I think I recommend you to use the general load first before go to the offshore load. Okay, you can go to the general load. After you go to the general load, it will be classified by many load, such as the in the nodal point for the frames point.
Can I have then, if we don't select the condition, it is free condition.
Yeah, that's right. It
It's
will be
free.
free. Correct. Don't have the constraint. So we have separate by the type of the load. This is the belong to the nodal load. This is belong to the frame, belong to the cabin, belong to the shell, and belong to the solid. Okay. In this example and verification, we use just three for the nodal point to test it, right? For the first load, then we need to test the extension. You can type by the name after you select it. Press the OK to confirm. This is the window form that we need to assign it. For the extensions at the endpoint, we apply force equal to the needed force. Apply at the free end. Add it. This is the number after we add it. Okay. And to add more load, we need to click plus sign belong to here. Type the name for the imprint. Choose what kind of the load you would like to assign it. I use the nodal load everything because just the right units, right? This is for the imprint. Add it. Okay, and then outprint. One for here and torsion. Okay, after everything is complete, you can see belong to here also. They have the arrow to specific where is the location that you assign on it. In-print, out-print, torsion. Okay, so after everything is complete, you can go to the calculate. Click calculate. Save the model.
Hello, just a second, dear student. If you see it in the screen, very, very clear, yes?
So, by the way, at the first thing, you need to make a folder. Do not save to somewhere because it will be have a lot of the file generated. It's difficult to delete and take it, right? Make a folder and put any kind of the name. I use the model. Okay. Now it is completed. After completed, everything will be shown belong to here for the result. But we have the option to be readable form in the XC Preprocess. Okay, we can go to the output list to show on the diagram. This is a beam and controller beam that defined it. You can see it's on the top part on it. We have the type. You can select the shape. What is the shape you would like to see it? Deformed or undeformed shapes, right? And this is a solid or scalar line. You can see select on the load head also that you define it. Because I defined on the extension, isn't it? We can see it's on the extension first. This is a step load. It's not belong to here. We can go to the displacement max extension. It should be you. You can see it's the number is 3 minus power minus 5. That's right. And we can check on the rappel to be shown on it and zoom it. That means the first value, I think this is correct. So if you would like to see it's on orthotype, just like the in-plane, and click on the displacement. In-plane should be V here with the value. Okay, right? But by the way, if you're not clear, you can click on table belong to here. It will be summary about the results. You can see this is a result that we check on the in-plane. And you can see it by yourself for the out-plane and the torsion. So this is everything. This is completed. By the way, we have the additional, if you're for the load combination in the future you would like to be checked and you would like to be used it. The load combination we put on the Preprocess. So you need to be run and calculate complete first before you use the load combination.
Just a second. Eventually, load we follow the SACS, SACS load combination in the Preprocess. But however, Midas post process is post load combination in post process. Later on, we found out the load combination, if load combination is a post process like Midas, much more convenient than SAC. So we recently we just changed all the load, we put the load combination in the post process. But later you may have a chance to use the SAC's load combination in the Preprocess. Not so much convenient.
Okay, this is a load combination. We can click here, modify and define the name of the load combinations. Press the OK to be confirmed tab. We can see it's on the right hand side of your columns, isn't it? Right? We can add it and select in-plane, out-plane, torsion, and find some factor. Maybe this is a double 2 times. Press the OK to be confirmed. And you can see it's on the Preprocess also on the load combination. We use the superposition, sorry. This is the map. This is when we combine it. Okay. Okay, this is for the first model for the cantilever beam, isn't it, right? But when you would like to be the starting about the second model, first you need to close the old model that you're working on it.
This is very important, yeah?
Yeah, please close it. And we allow just one model per one time for analysis. Do not open a lot of it.
Because this is a property of AutoCAD, yeah? Not related to XC. AutoCAD itself. So we have to close otherwise.
Okay. After you close it, you need to go to the Axis Preprocess. And you can see it's on the file system, isn't it? Please click the new every time when you do something. After you click the new, everything will be clear what if you assigned it. Because last time we already assigned it rectangular, right? But nowadays we don't have it because we already clicked new. It will be clear, everything is right off the data. So the second model, I will explain on the shell how to define and how to assign the shell element. So we use the verification name is the bending of the rhombic plate. So you can see it's on the second page as I show it to you. To model the shell element, you need to starting from the line and go to the shell for the AutoCAD. You can see we have the home solid surface. First, you need to draw in using the line tool, and second, you should be use the surface to generate the surface. Okay, for the rhombic plate, AutoCAD is easy. You can set on the 30, 60, 90 to be snapped, right? Click here for the first. Because of the length is equal to 1 with the 30 degree. I will enter here 1. Length here is 1. And when you back 151 and close it. Press ESC to be. Now we already have the line is a cover. To be generate the surface, we have the two options. The first is the network. Second is the I'm sure you cannot see well. Let me recommend it. You can see we have the network and planner. Both of it can be generated. The surface. Okay. So I will use the planner. It's more easier. Zoom it, zoom. We can use the planner here after we click on the planner. It will become commands, right? We can select by the object by press O. And you can see that the cursor is changing, right? Cover of it. Space bar to be entered. Now the surface is coming.
저 표시가 돼 나와야지만 우리가 스페이스 데이터를 알 수가 있어요.
One important thing, you need to check your model also. What is remaining? When you starting from the line to generate the surface, the line is still existed. I will check by using the quick property. You can see that we have 5 number, line 4, surface 1. By the way, when we send the value, send the model to the GMatch, we need to send just 3 surface, isn't it, right? You need to clear the data. Clear the line. You can see that the line still have it. 1, 2, 3, and 4. You need to delete it. After you check it by yourself, by selecting the quick property, you can see now the remaining just 1. Please be careful on this part when you use on the surface. So it is the same thing. You can go to the preprocess called the GMatch. But it will be generate one more method when you define the 2D generation. Go to the match, define. First, we need to use the time finite for the curve to make it a structure match. In example, I use the x by x, right? That means when I define the curve, I need to input number 9. Okay, cover all of the line, press E to be confirmed, save, quit. Second, we need to go to the surface to specify where is the surface that we would like to use the time finite. So now we have just only one surface. Maybe it's not clear. You can see on the dash bars, right? This is the surface that GMatch generated. Can click here. Maybe this is more clear. Press E to be confirmed and aborted. Now everything is confirmed. We can use the 2D to generate. However, this is the 3-node shell. If we would like to change 3-node shell to be the 4-node shell, we need to use the recombine option. Recombine 2D. After you click it, it will be combine from the 3 node to the 4 node. Maybe this is not clear. This is a 4 node child. As you would like to check it, we can go to the option match and to be element rabel, or even though there to be to defect here or node rabel. Okay, after you complete everything you already succeeded, just go to the file, save match, and go to the file again to be quitted the program, and then open match. Just wait a minute, because I used 2 times. Open match. Okay, now this is coming, and this is a match static. Actually, it's the same thing. I would not explain much about the solution. We can say on the linear, right? But in the model, we use the uniform load to apply on the rhombic plates. Second, we need to define the material on the materials, right? They define as the 3 multiplied by 10 power 7 again, and the Poisson ratio is equal to 3. Okay, so we can choose to go to the child element. We classify by the 4 node and the 3 node. This is belong to the 4 node, isn't it? Right? We can choose to be 4A and S. After we choose it, the window is coming, right? You can see we can define the material that you assign at the beginning. Choose the material and element thickness. The element thickness is equal to the 0.01. For the verification, cover all of it, add it, and then close it. This is our simple support. Then we go to the boundary for the restraint, cover all of the page. Add it. Yeah, it's 32 is correct. And after you complete it, for the boundary, go to the load, general load, as I mentioned it. Go to the shell element load. Now we would like to use the uniform traction because it's the global systems. So we can click on the uniform traction load. Click to be confirmed. Assign the vertical load to be tested. Maybe just -1. Cover all of it. Add it. So by the way, if you rotate the picture, you can see we have the symbols also. This is to rotate the picture. You can use this one. Okay, everything is same. After you complete on assign the loads, right? You can go to the calculate, press, and then require the saving file. We change another folder. I use the model. Okay, this is after completed. We can go to the Preprocess. Go to the output list, and this structure that we make it. Go to the displacement, W to be check it. This is a result. You can see this is a shaft. You can modify the scales also if this is too big to you. 0.5 to be the scale size of the shaft.
Can you show what post-processing?
Yeah, what kind, sir? Actually, we have the table. You mean that? yeah, if you would like to export, we have the option. You can see the options export to the Excel. You can save it, even though you can copy by clicking here to be copy and go to the Excel, press it, you can check all of it. If you would like to generate the report, we can go to the create the report belong to here by click it, input the project title. I would just simple by the DFA here, and then okay. Everything is will be included belong to here. So normally we have the additional options or so to be include the picture to the report, because in case of you certify this kind of the displacement, isn't it, right, or the displacement map. So when you certify so much, you can use this kind of the tool to snap to the report. After you click it, it will be show the message, a screenshot of the diagram was added to the report. After you click along to here, when you generate the report, that picture is will be put automatically on the page. This is what we're doing nowadays. And the professor would like me to show the OpenFAST, isn't it? This is the OpenFAST.
Very clean.
So nowadays we have the two options, the OpenFAST and OpenFAST. OpenFAST will be the program that connects to the XSys program. OpenFAST is the original OpenFAST. Maybe we didn't connect to our program, just run original program of the FAST. But in OpenFAST, we connect with our substructure to use it. It's more convenient. That means you can model. We'll show you one model. Because I test it also. This is our NREL jacket structure. Okay, we already defined as the OpenFAST. This is the OpenFAST menu. When we model something belong to here, the model, the data, everything will be entered to the data sheet automatically without any specific. You can see it's on the, we have the primary control belong to here by select on the substructure or many kind of the form, even though the modeling, if you include it or none, it will be shown and hidden. It's more easy to use it. Okay, we have the ice properties also. This is our OpenFAST. What we are talking, we have the, even though the health figure to be showing, it's not loaded. Okay, it's fine. Even though we can import the file, if you already have the file, you can import it. It can be live automatically and inserted. And you can see we already have the data provided instant. Professor mentioned about the NREL 5 megawatt, isn't it, right? This is the NREL 5 megawatt braid data. You can see check on the braid parameter, distribute property. You can use and choose it. No need to define by yourself, or if you have by your own, you can model by yourself and include by yourself also. Tower property also, we have the example. This is already provided for the monopile, tripod jacket, barge, haywind.
Does the power option influence the substructure?
No, this is not. The substructure is belong to the here. The substructure is belong to here, sir. This is different. By the way, this is a structural control. The structural control is for the tower. So, and aerodynamic control is just like on the top part and to generate the wind profile. Inflow is the same with the aerodyne. Operational control is just like the diving train or some component electricity inside the nacelle. So, substructure, this is the we modified it. and we have modified a lot of it. By the way, in the original form, it's have more than this. We have, by the way, we need to include some coordinates, right? But we cut it. The coordinate will be lead from the model from the AutoCAD already. That's why if you check the menu of the substructure, it will be reduced. I can show you with the file format. This is the original form of the substructure. If you compare with AutoCAD, you can see on the first is a simulation control. Actually, it's the same line by line. You can follow it. But after you go to the structural joint, it will be required to input inside the OpenFAST program, but we don't have it. We have just really the transition piece that you need to define the positions of the interface. Maybe before you confusing, I need to show you this term first about the structural control. It should be less to die.
Actually, original OpenFAST is very difficult to create the geometry. But if you use the XC drawing tool, we can create the offshore structure geometry very easy.
In OpenFAST, we have allowed, as I count allowed 13 files you need to input by hand. This is the original file of the OpenFAST. We make the interface and compatible with the original file. Everything is the same. You can see that when you show on the simulation control, they have the simulation control belong to here also. They use the echo to be on and off. You can see every detail is the same. Integration method. They have the 3 options. We have the 3 options also. They set number 3, and we can choose it for the interface. You can see they have the degree of freedom to be true and false to be set it. We have belong to here degree of freedom by using on and off. Everything is almost same with the original, but when we connect with the OpenFAST, we cut some part out, just like the provide the coordinate, because we can model, isn't it, right? We can use this coordinate to provide in the OpenFAST file, such as the hydro die, sub die. This is a very special issue part when we make the program. You can see we have in the turbine, they have many kind of the condition. When we define number of the beds, right, they have the 2 bed or 3 bed. So if you use the text, I think it will be confused because some part will be one working. Especially as I show you, you can see this is the platform. Here, this is the platform. Platform, this one belong to the floating structure. When you use the fixed structures, right, you don't need to input anything. But inside our program, we already provide and correct more easier than you define by yourself, or number of the bed. Also, when you define the number of bed equal to the 2, the rotor theta, it should be included. Like this way. Maybe we can discuss later on about the OpenFAST if you understand clearly and how to do on the starting to make the model.
So I think after you practice some of static and the dynamic, then okay, then before you start the coupled analysis, we will make some tutorial through the Zoom meeting again about the OpenFAST. So before the time, you can just concentrate XC.
Okay. Inside the folder, I think I give you the simple model. You can check it also. Maybe we have the linear dynamic, linear static, belong to here. You can see the linear static NRELs, right? When you would like to check the model, you can click on the open and choose the XSM file that we are saving. Go to inside the folder, maybe linear dynamic here. Please open at the XSM file. This is a saving file.
XSM을 클릭하면
Okay.
if you click it,
You can change it. And maybe this model I didn't correct for the heuristic. This is already considered the local. Yep. That's why it's overlap a bit. You can see even though the BOM, if you would like to calculate the cell weight, I think this is the answer also. Cell weight of the structure.
BOM, bill of material. So if you click BOM, you can get the total weight.
So here the swap.
Swap.
Yeah, no, swap it.
So already. Swap means at the time this was at the primary make a mistake. We make wrong direction. Then if you use swap, we can
change the local axis.
Local correct.
Begin and end. When we counted, we need to know that where is the begin position and end position, right? So we can swap it. This is will affect on the right hand side loop when you rotate on it.
So this graphic is developed at some of other company. The company is very good. The graphic development company, very professional company. They developed this for us. We are working together.
So you can see on the offset.
Offset. Rigid offset. Yeah, you can see this one. Yeah.
This is offset.
Can you make it too? You can see that this connection we know is very clearly offset. Eh?
You can see that if we didn't use the offset, the joints will be overlap.
Overlap, yeah. Then
we can use the automatic. Add it. This is after we adjust it. Can enable, disable, enable.
So everything can be done in the AutoCAD. This is a very surprising actually. All are done in the AutoCAD.
You can see after we use the offset, this is what is the joint look like. Cannot see well. You can see it's not connected. You can see it has some space, isn't it, right? If without offset, the joint will be connected with the line.
I think later on you can check one by one. You can learn that. Offset. So today this is it. Okay. So you what?
By the way, should we record what you present?
Which one, sir?
On record.
Yeah, I already have it. I can give it to you, sir.